we have another question. So they're saying a constant force F pulls a strong 50-kilogram block at a constant speed. Remember what we said, if it says constant speed, then it means what? Acceleration equals to 0. So which means all the forces in your vertical axis, all the forces acting along the y-axis, they will be equals to 0, right? Over a rough surface, again, rough surface, what does this mean? There's a presence of what? The frictional force. The coefficient of kinetic friction between the block and the surface is 0,4. So what is this 0,4? This 0,4, it's mu k. So this is the coefficient of kinetic energy. So we have you could either calculate your frictional force using the first method that we did in the first video, or this one. And this one, you only use it if you have the coefficient of kinetic friction, right? Now, for interest's sake, let's just draw the free body diagram, right, of all the forces acting on this object over here. So we're going to have normal force, which is acting perpendicular to the surface. Then we're going to have m dot g, right? Then we're going to have force applied, which is 100 Newton. Then we're going to have Fk in the opposite direction, right? So now what did they say? We should calculate Fk. So as I said, that if we have mu k, which is the coefficient of the kinetic frictional force, our Fk will take this formula. Fk will be equals to mu k multiplied by the normal force. But firstly, before we can calculate, we don't know what the normal force is, so we have to work out what the normal force is first, right? So now let's go back to our diagram, to our free body diagram, right? Let's look at Fn. In order to get Fn, we need to also get the y component of this applied force. So fine, let's break it down into its components, right? It will look like this. This is our Fn over here. Oh, remember, guys, if you're required to draw a free body diagram, do not draw this one. Draw this one whereby you did not break down the force applied into its components, please. Thank you. So it'll be Fk going downward. It'll be m dot g. Then going that way, it'll be your Fk. Sorry, just ignore this. Sorry, by the way. And then when we break down this force applied into its components, we're going to have an x component, right? And a y component. This will be F cos theta. This will be your F sine theta, right? So as I said, they said it's what? It's a constant force F pulls a block of 50 kilogram at a constant speed. So what does a constant speed mean? It's just telling us that these forces in the y-axis, they are equals to 0. Why? They are balancing one another out, right? So now we need to get all, okay, let me just say for normal force, we need to get the normal force, right? So that we can able to substitute it over here, so that we can get our kinetic, so that we can get our frictional force, right? Okay, fine. So for normal, we're going to say Fn, which is over here. Sorry, this is Fn, by the way. So in order to have Fn, we're going to say Fn plus F sine theta minus, because we took our up as what? As positive. So it's going to be Fn plus F sine theta minus mg equals to 0. Why is it equals to 0? Because we said, since, well, they said that there's no acceleration on this, a equals to 0, right? So that all the vertical forces acting on this object, they will be equals to 0. That's practically what they mean when they say there's a constant speed, right? So we're going to have Fn plus F sine theta minus m dot g equals to 0. Now let's substitute them because we know these, right? So we will have Fn plus, what is our force? It's 100 sine of, what is theta? 30 minus, what is our m? 50. What is our g? We all know it at this point, 9,8 equals to 0. So we can work out what this is with our calculator and then transpose it. So our Fn will be equals to, before I say equals to, when we work this out in our calculator, it's giving me negative 440, which will be equals to 0. Now, because we're trying to figure out what Fn is and we want to make it the subject of the formula, we can just take this take this negative 440, transpose it to the other side. So we'll have Fn equals to 440 Newton. Now, at least do we have what? Our Fn. So now, because we have our Fn, we can just substitute it here in order to find what we're actually looking for, which is what our frictional force. So let's now do that. So we said Fk equals to mu k multiplied by the normal force. Should I write it here or here? I think let's write it here, sorry. So we said Fk equals to mu k multiplied by the normal force, which is just, what is our mu k? It was 0,4. They gave it to us in the question statement, right? So it will be 0,4 multiplied by, what is our normal force now? Our normal force is 440. So when you punch this into your calculator, it will give you Fk as 176 Newton, right? So this is another way in which you can find your frictional force, provided that they gave you the coefficient of kinetic energy. Yeah, that's how it differs from this one. This one we were not given the coefficient of kinetic energy, but this one we were given the coefficient of kinetic energy. Do you guys understand both of these? Please get back to me.